This is section 4.4 of Timberlake Basic Chemistry, and we're looking today at atomic number and mass number. So these are simple ideas, but important ideas. If you don't understand this, so much that you're going to try to build on will fall. So these are just simple ideas that everyone has agreed to use, so it'll help you to do it. We'll see that this is sulfur, a picture of sulfur. It's a yellow powder. It's brittle. It's not metallic. It doesn't pull into wires. It would crush if you touched it with your hands. And we're going to see that atomic number here is at the bottom. All of these are 16. The mass numbers here at the top are different. That means there's 4 different types of sulfur. It's still sulfur. Sulfur will be defined to be anything that has 16 protons. So we'll see that the atomic number is the number of protons, but the mass number is the number of particles in the nucleus. And these are protons and neutrons together. So they're considered to be nucleons. They're in the nucleus, and protons and neutrons both are considered nucleons. So this number, 32 in this case, 33, 34, 36, are the different forms of sulfur based upon their weights. So if there are 16 protons, then there must be 16 neutrons in this case, 17 here, 18 here, and 20 here. So even though there's different weights, it's still considered sulfur, but these are different isotopes. We'll look at that in the next section. So its atomic number is specific because it's the number of protons in that particular element. So an elephant is defined by the number of protons it has. So in a periodic table, it usually appears at the top, maybe the top right corner or the top of the square in the periodic table above the symbol. So in the case of hydrogen, there's 1 proton, so therefore it has atomic number 1. For copper, there's 29 protons. Copper has an atomic number of 29. So this is pretty simple. So here's lithium. Lithium is got 3 protons. Its atomic number is 3. So here we've got the, I think it's red in this case, red protons. So there's 3 protons. We'll see that it has an atomic mass. There's 4 neutrons here, so it has an atomic mass of 7. All right, so that's its mass number. We'll look at in a minute. And then electrons is going to be equal to the number of protons, and they spin on the outside of the nucleus. So the nucleus has these massive protons and neutrons, and the electrons are in a cloud or on the outside. So since these are neutral, since every element on the periodic table is not charged, that means its positive and negative have to balance. So if there are 14 protons in the nucleus, there will be 14 electrons in the outer shell in order for it to be neutral. So it doesn't matter what it is, they will add up to 0. The protons plus electrons will always cancel, so therefore they're going to be equal in number. So an example, you have hydrogen has an atomic number of 1, therefore it has 1 proton. It will also have 1 electron. Now we'll see when we get to mass number that the mass number is going to be the number of protons and neutrons. And so in this case, if it has a mass number of 1 and an atomic number of 1, there must be no neutrons in the case of hydrogen. So I hope that helps. It's very basic, and I hope you're getting it.